Number 4, torque problem worksheet. Torque is awesome. Now in this problem, I'm going to use this. For the other problems, what I did is I redrew my own free body diagram, but I'm just going to use this as our free body diagram. Do it right on here. So we're going to do the free body diagram for this bar. Notice that the bar, and I'm going to be honest with you, when I first did this problem, I got it wrong. You want to know why? You want to know why Spaldo got it wrong? Because I forgot to include the mass of the bar. I did it just off the diagram with those forces, and I'm like, oh, I looked at it, I forgot the mg for the bar. So let's put this in here right now. So the mass of the bar is 25 kilograms. Where do you put the the weight of the bar? Directly in the center, so like right about there. So mg for 25. This whole worksheet, use gravity as 10. So 25 times 10 would be 250 newtons. Okay, this 15 kilogram weight hanging off here, 15 times 10, 150. So let's put that in there like this. So this is basically a force right there. That's 150 newtons pulling down. This 10 kilogram box over here, 10 times 10 is 100. So this is going to be 100 newtons pulling down right there. Then over here, 5 mg for 5. That's 5 times 10. That's 50. Okay, so we got this looking real nice. And then these are forces, right? Tension 1 pulling up, tension 2 pulling up. And then the only distance that we're going to have to figure out here is for the 250, because that was added later. So all these distances are in meters. Now, what we're trying to solve for here is T1 and T2. The question is, what are the tension in the two wires? We're solving for that tension, and we're solving for that tension. Now, you know from math class that if you have two unknowns, you got to have two equations. So how could we get two equations? Well, we can sum the forces. So let's do that first. Let's do our first equation. We can sum the forces. Now, sign convention for forces, it's easy. Up is plus, down is minus. Easy for cheesy. So we go T1 up, T2 up, right? They're both positive. Then minus, let's just do these all collectively, right? I mean, we could do them individually, but that'd be really long. So let's see, 50 plus 250, 300. So that's what, 550? Everybody with me? Let's just do them as a group. I mean, we could have done them individually, but that just makes it long. Okay, sum of the forces equals MA. Is this bar accelerating or just hanging there? It's just hanging there. So the A goes to 0. Okay, so this is just going to be 0. So technically it equals MA. Technically it equals MA, but the A is 0. Okay? All right, that's the sum of the forces. Now, can we solve for T1 and T2 from there? Nope. But I have an idea. We've been talking about torque, so why don't we sum the torques? Okay? Now look, if we're going to sum the torques, we got to choose an axis. Now this problem doesn't have an obvious axis, but I'm going to tell you what, we either want it to be here or there. Now having said that, does it have to be one of those 2 points? No, just be aware. If you really wanted to, you could put your axis like there, as long as you define exactly where that point is. You could be like, all right, 1 meter from the left, that's the axis. It'd be fine. You could do it, but let's make life easy. Raise your hand if you like life easy. Push the easy button. If you want to push the easy button, if you're pushing the easy button, where should your axis be? Either here or here. Now, why would that make life easy? Because forces on the axis cause no torque, right? So I'm just going to tell you what I'm making the executive decision. For this video solution, our axis is going to be here, okay? Now, why is that going to be really nice? Because if that's our axis, T1 will not be in our summing of the torques. Does that make sense? If a force is on the axis, the torque for that force is 0. Okay? So we got all our distances here. So look, we got, look at boom. So we're measuring from there, right? Let me do red. I'm going to do red. Put this in red so you don't think it's a force. Okay, so we got this in red. So we're measuring distances from this red line because that's the axis. So we got 2 meters. That's 2 meters, 1 meter, like that. So we got all these distances here. And then the distance to the 250, what's this distance in there? From the axis to the 250 is what? 1 meter. All right. Now, let's identify clockwise, counterclockwise. You gotta know where the axis is to do clockwise, counterclockwise. Okay, so what's the 100 doing? Clockwise or counterclockwise? Clockwise. 150? Clockwise. The 250? Clockwise. T2? Counterclockwise. The 50? Counterclockwise. It's like trying to pull it. You know, you got to pay attention to where the axis is when you're doing clockwise, counterclockwise. So let's say that all the clockwises are plus, clockwise plus, clockwise plus, counterclockwise will be minus. You like this, don't you? Okay, so now we're ready to sum the torques. We're doing our second equation here. So let's start with the positive torques. Let's start with this 100 here. So remember the torque equation? Torque is force times distance, but they have to be perpendicular, and R is measured from the axis. So what's the R going to be for the 100? So let's see, from the axis all the way over to there. How far is that? 4, and that's perpendicular. So this is going to be 100 newtons times 4 meters, right? Force times distance, perpendicular from the axis. Okay, 100 times 4. Okay, let's go to the next one. 150 is our next positive. So positive plus 150. Now what's the distance for the 150 from the axis? What is that? Is that just 2? 2 meters. Yep, 2 meters, and it's perpendicular, so we're good. All right, and then the last one is plus, not the last one, the last positive one. 250 times 1, right? 1 meter from the axis, perpendicular. Okay, so those are the 3 positive torques. Now, let's do the negative torques. Minus T2. What's the distance for T2? The distance there is 3. Right? From the axis over to T2 is 3 meters. Negative because it's counterclockwise. All right, and the last one is the 50. Minus 50 times, what's the distance there? 2. Oh, just enough room. All right, so the sum of the torques will equal what? 0. Ooh, I just barely squeezed that in. All right, so look at this big, long equation here. See that big equation right there? It looks all scary, but it's not scary. What's the only thing you don't have in that equation? T2. Hey, I want to show you. Hey, do you want to know why that's so nice? Because where did we pick the axis? T1. Notice that T1, guys, hey, notice that T1 is not in our summing of the torques because it's on the axis. Okay? All right, so you solve this for T2. T2, when you do this, comes out as 283. Now, how do we get T1? So go back to our first equation up here. So if you rearrange the first equation, T1 is going to be 550 minus T2. So T1 comes out as 267. All right, now, guys, just to make sure that you totally understand this, redo the summing of the torques. Do the summing of the torques again, but have this be your axis. Move the axis to where T2 is. Will you get the exact same thing?
Yes.
For sure. Yo.
Why is T2 moving counterclockwise?
Because, so the axis is right here, right? Here's my axis, right? T2 is pulling that way, right? That's counterclockwise. And then same thing for the 50. The 50 is pulling that way, which is counterclockwise with the axis right there. You have to know where the axis is for clockwise, counterclockwise. All right, good job.